Okay, for naming compounds, ionic compounds, what we're going to do is we're going to break up the metals into two different groups, really. What we're going to do is we're going to say the groups that we know of, group 1A, are going to be plus ones. Now if you look at your periodic table, those are the alkali metals, group 1A, so potassium, lithium, potassium, sodium, blah, blah, blah. Group 2A are going to be your alkaline earth metals. They're going to have a plus 2, and you should definitely have that written on your periodic table. So those are like barium, calcium, those metals, that whole family. Going over to 3A, that's a little harder to find, but if it starts with aluminum, and then gallium, and then thallium, and then downward, and those are going to be plus 3s. We're going to depend upon that. Some other things we're going to absolutely depend upon, and we want to write those on our table, are zinc's a plus 2, silver is a plus 1, and cadmium's a plus 2. Now we're going to basically say this is pretty black and white. These metals we know, absolutely know what charge they are. They never do another charge. And the rest of the metals, any other metal you can find on the table, can do multiple charges, and we're going to have to do something different with those. Now I know on your table you have little charges in the boxes, and I really want you for the most part to ignore those, because we're going to just break them up into, yes, we do know the charge and these are they right here, or we don't know the charge and we're going to have to do something a little bit different than I'm going to show you right now. Okay, so for those that we do know the charge for sure, all we're going to do is we're going to name the metal and then we name the nonmetal. Now these numbers actually are supposed to be subscripts. For some reason they don't transfer that way into Dropbox or explain everything, but they're supposed to be subscripts down beneath. Okay, now we actually don't even really care so much about the charges on the aluminum or the oxygen. We actually know those. We know aluminum's a plus 3, we know oxygen's a minus 2. And so it makes sense to us that we're going to need to have 2 of those aluminums, 2 of the plus 3s, and we're going to need 3 of the minus 2s. But honestly, the charges don't play in much here. It's just called aluminum oxide, zinc bromide. So, and then if you go backwards, sodium fluoride, the one thing I would do here differently is instead of just writing it, at least at first, is I would go to the table, I would write the ions, and know the charges because we've written them on our table and realized that a plus 1 and a minus 1 will be that. A magnesium sulfide, again, a magnesium's in group 2. A sulfur's in the oxygen family, so minus 2. So it makes sense, one of each, to make that 0 net charge. If you had something like gallium selenide, okay, just as another example, I, again, would be really careful and write out the charges before I wrote the compound. So I would go back here and say, okay, gallium is a plus 3. I know that. It's in the group 3. And selenium's in the oxygen family, so minus 2. And so this compound, I'm going to need 2 galliums and 3 seleniums. So that is the compound. And again, if you want to keep those charges up there, that's perfectly fine. Now, here's the other type of metal, the metals that we don't have anything written for on the table. What we're going to have to do is we have to calculate the charge, which is not a huge deal, but we have to do it. And once we do, we're going to put that charge in parentheses and with a Roman numeral. Now, rookie mistake here for this example, people call this copper 1 sulfide and they call this copper 2 sulfide. And that's a rookie mistake because this number does not represent how many coppers there are, it represents the charge. And so we have no idea what the copper could be. I think on your table you see a little plus 1 there, a little plus 2, but it's not one we wrote down. But what we do know is that sulfur is a negative 2. We know that the oxygen family is a negative 2. Well, if this is going to be positive, or come to a 0 net charge, then that has to be plus 2. So this is where this 2 is coming from. In the same sense, here I've got a sulfur at a negative 2. I just have the one sulfur. Over here it has to be a plus 2 because they have to be 0, but there are 2 coppers, each one carrying a plus 1 charge, and that's where that plus 1 comes in. For here, we don't know. Again, chromium is not one we know. Sulfur is a negative 2. There's 3 of them. This has to be positive 6 if that's negative 6, and there's just that one chromium there, so that has to carry the plus 6 charge. Down here, though, we have sulfur at a negative 2. There are 3 of them, negative 6, plus 6, but now we've got 2 chromiums to carry that. And so that's where we're going to get that plus 3. Okay, and then going backwards, again, I would absolutely encourage you to write out the charges, okay? before you put it together. But you know that iron's a +3 from that Roman numeral. You wouldn't know it from the table. And you know that nitrogen's a -3. That you know from the table. +3 -3, 0 net charge, 1 of each. Again, iron 2 oxide, that +2 is coming from that Roman numeral 2. Oxygen we know is a -2, 1 of each. Cobalt 2, I know that means there's a +2, and I know fluorine's a -1. So it makes sense, I'm going to need to have 2 fluorines. That's the compound. And here, Fe +2 and -3, I know I'm going to need to have 3 of those irons and 2 nitrogens to get a +6 and a -6. So Fe3 and 2. Okay, now we're going to throw polyatomic ions into the mix, and before you even do this, you should be looking at page 117 to become familiar with those polyatomic ions. You also know there are 5 of those I'm telling you that you need to memorize, and you want to memorize those for a quiz we're going to have. But again, we're going to put them with our 2 groups of metals. The groups of metals that we know the charge, absolutely. I didn't put cadmium here, but cadmium's a +2. Zinc's a +2, silver's a +1. But what we're going to do now with those metals we know the charge of, we're going to put them with a polyatomic. And all we do, because we know the charges on these things, is we just name them. Sodium sulfate. Now this tends to be a little more confusing because this really should be, these numbers should be subscripts. But sulfate, there is just one sulfate there. Make sure you're okay with that. And charge-wise, this works out for 2 sodiums because sodium carries a +1 charge. I need to have 2 of them there to make a +2 because sulfate, that one sulfate, carries a -2 charge. And I didn't really need to know that to make it sodium sulfate, but there you have it. Potassium phosphate, phosphate carries a -3 charge. Each potassium is a +1, but we know that, again, this is not necessary, potassium phosphate. Aluminum phosphate, aluminum carrying a +3, a phosphate carrying a -3, 1 of each. Acetate, look that up on the table. There are 2 of them here, and that makes sense because calcium carries a +2 charge. I'm going to need to have 2 acetates. But again, to name those, it's pretty straightforward. You just name it and name the polyatomic. If you go backwards, again, I can't overstate this enough, I would go ahead and write the ions. Zinc +2 is right from your periodic table. Nitrate -1 is one you do need to memorize, but it's also right there in the back of your periodic table, or on page 117, nitrate. Now, because of this +2 and this -1, I'm going to need 2 nitrates and 1 zinc. This 3 right here, don't bother a thing with it. Once you write it down as NO3, it's a nitrate. Do not even consider it anymore. Just forget about it. It's these charges we worry about. Magnesium hydroxide. Magnesium's a +2, hydroxide's a -1. I'm going to need 2 hydroxides. Make sure you put those parentheses in there. Aluminum chromate. I know from the table aluminum's a +3, and chromate is actually a -2. Goofy thing. And so what that means is that aluminum is a +3 and chromate's a -2. I'm going to need to have 2 aluminums and 3 chromates. So it should look like this. Okay, that's a 3. And these should be superscripts. I don't know why they don't change. They do that, but anyway. Okay, and then lastly here for this video, what if we have those metals that we don't know its charge? These will be the most challenging because what you have to do is you have to recognize that this is a sulfate and there is just one sulfate. It just so happens that a sulfate is a sulfur and 4 oxygens, but that is a sulfate and there's one of them. It carries a -2 charge. That has to be +2. There's only 1 copper there. It's going to have to carry it. Phosphate is a -3. There are 2 of them. It's a -6. That has to be a +6, but there are 3 irons. Each of them going to carry a +2 charge. Chromium 3 phosphate, why? Well, because a phosphate is a PO4 and there's 1 of them there, it carries a -3 charge. There's just 1 chromium, it's going to have to carry that +3 charge. And then again, going backwards, again, you are definitely going to want to write these ions out first. Nickel +3, I wouldn't know that other than there's a Roman numeral. Chlorate is a ClO3 with a -1 charge. This is a subscript. This is a superscript. Be careful there. This is what it's going to look like. I'm going to have 1 nickel and I'm going to need 3 chlorates. Again, do not pay any attention to that 3 once it's written correctly. Definitely write it correctly, but once it's done, you're done. Zirconium +2. There's a +2. A permanganate is an MnO4 with a -1 charge. Because I'm looking at a +2 and a -1, I'm going to need 2 of those. Tungsten 5-dichromate. Ooh, okay, tungsten is from the Latin root wolfram, so that's where the W comes from. And then dichromate, a very pretty but highly carcinogenic compound. So what am I going to need? I'm going to need 2 tungstens, and I'm going to need 5 dichromates to give me a +10 and a -10, 0 net charge. And that ends the first video.